Imagine standing on a world where the ground beneath your feet is constantly melting away. Picture a place straight out of your wildest nightmares, where hundreds of volcanoes spew glowing lava tens of miles into the sky, where bubbling lakes of sulfur stretch across the horizon, and where earthquakes shake the ground without pause. This isn't some far-fetched science fiction scenario or a scene from the latest blockbuster movie. This is the very real world of Io, Jupiter's innermost large moon and the most volcanically active body in our entire solar system. When Galileo Galilei first spotted this remarkable moon through his telescope in 1610, he could never have imagined the hellish landscape that future generations would discover. Today, we know that Io is a realm of perpetual destruction and rebirth, where the surface is constantly being reshaped by powerful forces that would make Earth's most violent volcanoes look like mere sparklers in comparison. Think about this. While Mount Vesuvius's famous eruption that destroyed Pompeii sent ashen rock about 4 miles high, Io's volcanic plumes can shoot material more than 300 miles into space. That's higher than the International Space Station orbits above Earth. Some of Io's volcanic lakes are larger than entire countries on Earth, and its surface temperatures can reach a scorching 3,000 degrees Fahrenheit. Before we dive deeper into this fascinating alien world and uncover its mysterious secrets, hit that like button and subscribe to Exploring the Universe. Trust me, you won't want to miss what's coming next as we journey through the most extreme and incredible places in our cosmic neighborhood. What makes this desolate moon so violently active? How does it maintain such intense volcanic activity? And could this hostile world teach us something about the potential for life in our universe? Stay tuned as we unravel the mysteries of Jupiter's volcanic powerhouse. On a cold winter night in 1610, an Italian mathematician and astronomer named Galileo Galilei made a discovery that would forever change our understanding of the cosmos. While peering through his handmade telescope at Jupiter, he noticed something extraordinary: 4 bright points of light dancing around the giant planet. These weren't stars, they were moons, and among them was Io. At the time, this discovery was nothing short of revolutionary. It challenged the deeply held belief that everything in the heavens orbited Earth, and it got Galileo into quite a bit of trouble with the Catholic Church. He named these moons the Medicean stars, after his patrons, the powerful Medici family. Today, we know them as the Galilean moons. For nearly 4 centuries, Io remained just a tiny dot in our telescopes, its secrets locked away behind a veil of distance. Astronomers could track its orbit and measure its size, but its true nature remained hidden. Some noticed its peculiar reddish-yellow color, but no one could have guessed what caused it. Everything changed in 1979 when NASA's Voyager 1 spacecraft made its historic flyby of Jupiter. What the spacecraft revealed left scientists absolutely stunned. Instead of finding another cratered dead world like our moon, they discovered a living hell. The images beamed back to Earth showed something unprecedented: actual volcanic eruptions happening right before their eyes. Linda Morabito, a navigator for NASA's Jet Propulsion Laboratory, was the first to spot a volcanic plume rising from Io's surface. She described it as looking like an umbrella of gas and debris extending nearly 200 miles into space. This wasn't just any volcanic activity. Io turned out to be the most geologically active world in our entire solar system. Scientists who had expected to find another quiet, cratered moon instead found themselves staring at a world that literally turns itself inside out through constant volcanic activity. The Voyager mission transformed Io from a mysterious point of light into one of the most fascinating and extreme worlds we've ever discovered. The story of Io's discovery spans from a simple backyard telescope to the frontiers of space exploration, reminding us that the universe is often far more spectacular than we could ever imagine. It's a perfect example of how scientific exploration can reveal wonders that surpass even our wildest dreams. What makes Io such a volatile world? The answer lies in a fascinating cosmic dance that would make any choreographer jealous. Imagine Io as a performer in an eternal ballet, but instead of dancing solo, it's caught in a gravitational tango with mighty Jupiter and its neighboring moons, Europa and Ganymede. This celestial choreography, which scientists call orbital resonance, is perhaps the most dramatic dance in our solar system. For every single orbit Ganymede makes around Jupiter, Europa completes 2, and Io spins around 4 times. This precise timing isn't just a cosmic coincidence, it's a deadly waltz that spells disaster for Io. Think about what happens when you squeeze a rubber ball. Now imagine Jupiter's immense gravitational force doing the same to Io, but on a massive scale. As Io orbits Jupiter, the giant planet's gravitational pull literally stretches and squeezes the moon like a cosmic stress ball. When Io moves closer to Jupiter, it gets stretched out like taffy. When it moves farther away, it contracts back. This happens every single time Io orbits Jupiter, which takes just 42 hours. But here's where it gets even more interesting. The nearby moons Europa and Ganymede add their own gravitational tugs to this violent dance. Their combined forces create what scientists call tidal heating, and the effects are devastating. The constant stretching and squeezing generate an enormous amount of heat inside Io. So much heat that it maintains a vast ocean of molten rock beneath its surface. To put this in perspective, imagine if Earth's interior was being kneaded like bread dough every couple of days. The amount of heat generated inside Io is about 100 times more than all of Earth's volcanoes combined. This tremendous heat has to go somewhere, and it finds its way to the surface through hundreds of active volcanoes. This destructive dance has been going on for billions of years, and it shows no signs of stopping. It's a perfect example of how the seemingly empty space between planets is actually full of invisible forces, powerful enough to turn a moon into a perpetual volcanic inferno. In a way, Io is caught in an endless cycle of destruction and renewal, forever dancing to Jupiter's gravitational tune. Let's talk about volcanoes that would make Mount Vesuvius look like a backyard science fair project. On Io, we find some of the most spectacular volcanic features ever discovered, and they truly defy imagination. The undisputed king of Io's volcanoes is Loki, named after the Norse trickster god, and believe me, it lives up to its namesake. This behemoth is literally larger than all of Earth's volcanoes combined. Imagine a volcanic caldera more than 125 miles across, containing a lake of perpetually boiling lava. That's Loki. It's so massive that astronomers can actually observe its eruptions from Earth, appearing as bright flashes on Io's surface. But Loki isn't the only showstopper on this volcanic moon. Meet Pele, named after the Hawaiian goddess of fire. This volcanic giant puts on displays that would make any fireworks show look pathetic in comparison. During its most powerful eruptions, Pele can launch material an astonishing 300 miles into space. To put that in perspective, that's higher than the International Space Station orbits above Earth. The plumes are so massive that they create enormous red rings on Io's surface, stretching hundreds of miles across. The lava lakes on Io are equally mind-blowing. While Earth's largest lava lake in Mount Nyiragongo is barely half a mile across, Io's molten lakes can stretch for dozens of miles. These aren't just pools of melted rock, they're vast seas of liquid fire, constantly churning and bubbling with intense heat. Speaking of heat, the temperatures on Io are absolutely incredible. The surface can reach up to 3,000 degrees Fahrenheit. That's hot enough to melt iron, nickel, and even some types of rock. This extreme heat comes from the constant volcanic activity, making Io's surface a literally ever-changing landscape of fire and brimstone. If these astronomical numbers and volcanic feats have blown your mind, don't forget to hit that like button. I'm curious to know, Which other world in our solar system would you like to explore next? Maybe the ice geysers of Enceladus, or perhaps the mysterious methane lakes of Titan? Drop your answer in the comments below and make sure you're subscribed to Exploring the Universe for more incredible journeys through space. Remember, our cosmos is filled with wonders that make even our wildest science fiction seem tame by comparison, and we're just beginning to uncover its secrets. Just when you think you know everything about Io, this fascinating moon throws another curveball at us. Let me share some mind-bending facts that showcase just how extraordinary this volcanic world really is. First, imagine a world that completely reinvents itself every million years. While that might sound like a long time, in astronomical terms, it's just the blink of an eye. Earth's oldest rocks are over 4 billion years old, but on Io, nothing stays the same for long. The constant volcanic activity buries older surface features under fresh layers of lava and sulfur, making Io's surface one of the youngest in the solar system. It's like watching a planetary-scale recycling program in action. Here's another fascinating detail. Io has an atmosphere, but it's nothing like what we're used to on Earth. It's an incredibly thin veil of sulfur dioxide that comes and goes with the moon's volcanic activity. When Io moves into Jupiter's shadow and the temperature plummets, this atmosphere actually collapses and freezes onto the surface. Then, when sunlight returns, the frozen gases sublimate back into a temporary atmosphere. It's like watching the moon breathe. Speaking of spectacular shows, Io's volcanic eruptions are so powerful that astronomers can spot them from Earth. Imagine being able to see volcanic explosions happening nearly 400 million miles away. The first Earth-based observation of an Io volcano was made in 1979 by amateur astronomer Richard Flagg using a relatively modest telescope in Hawaii. Since then, astronomers have documented hundreds of eruptions from our home planet. But perhaps the most surprising fact is how Io influences mighty Jupiter itself. This relatively tiny moon actually helps create Jupiter's massive magnetic field. As Io spews out tons of electrically charged particles through its volcanoes, these particles get caught in Jupiter's magnetic field, creating a donut-shaped ring of intense radiation around the giant planet. Scientists call this the Io plasma torus, and it's so powerful it can affect Jupiter's auroras and even interfere with spacecraft communications. The interaction between Io and Jupiter creates an electrical current of about 3 million amperes. That's enough electricity to power several major cities on Earth. This electrical connection forms a kind of invisible bridge between the moon and its parent planet, making Io not just a passive satellite, but an active participant in shaping Jupiter's magnetic environment. These incredible features make Io not just another moon in our solar system, but a unique laboratory where we can observe extreme geological and physical processes that we simply can't find anywhere else in our cosmic neighborhood. It's a reminder that even after decades of study, our solar system still holds amazing secrets waiting to be discovered. Io isn't just a spectacular light show in Jupiter's neighborhood. It's a natural laboratory that's revolutionizing our understanding of planetary science. Think of it as nature's own research facility, operating 24/7, conducting experiments on a scale we could never replicate on Earth. For volcanologists, Io is like hitting the scientific jackpot. By studying its extreme volcanic processes, scientists can better understand how volcanoes might have behaved on early Earth, when our planet was much more geologically active. The mechanisms behind Io's massive eruptions are helping us develop better models for predicting volcanic behavior, not just on Earth, but potentially on other worlds we might discover. But the learning doesn't stop at volcanoes. Io is teaching us invaluable lessons about how moons form and evolve. Before we discovered Io's intense activity, scientists assumed that moons were generally dead, frozen worlds. Now we know that moons can be just as dynamic as planets, sometimes even more so. This knowledge is completely changing our understanding of how planetary systems develop and evolve over billions of years. The interaction between Io and Jupiter is particularly fascinating to astronomers. It's like watching a cosmic version of cause and effect. Every burp and hiccup from Io's volcanoes affects Jupiter's massive magnetic field, creating patterns and phenomena we never knew existed. This discovery has led scientists to look for similar interactions in other planetary systems, both in our solar system and around distant stars. Perhaps most intriguingly, Io is helping us rethink what makes a world potentially habitable. While Io itself is far too violent to harbor life as we know it, its intense geological activity raises interesting questions. If geological activity can be maintained through tidal heating, could this mechanism support life on other worlds? This question has led scientists to look more closely at moons like Europa and Enceladus, where similar tidal forces might maintain liquid water oceans beneath their icy surfaces. The implications of studying Io extend far beyond our solar system. As we discover more exoplanets orbiting other stars, the lessons learned from Io help us understand what we might find out there. Could there be other worlds experiencing such intense geological activity? How common are tidally heated worlds in the universe? These questions, sparked by our study of Io, are driving new research and exploration. Scientists are also using Io to test and improve their computer models of planetary processes. When you can observe real-world examples of extreme geological activity, you can better predict how these processes might work elsewhere. It's like having a full-scale model that helps validate or correct our theoretical understanding of how planets and moons behave. In many ways, Io serves as nature's own peer-reviewed journal, constantly publishing new data about volcanic processes, tidal heating, and planetary interactions. Every observation, every new discovery about this remarkable moon adds another page to our understanding of the cosmos and our place within it. As we conclude our journey through this remarkable Jovian moon, Io stands as a powerful reminder that our solar system is far from being a static, lifeless place. In fact, it's a cosmic laboratory where titanic forces sculpt alien worlds in ways that push the boundaries of our imagination. When we gaze at Io's volcanic eruptions from space, watching fountains of lava dance across its sulfurous surface, we're witnessing more than just a spectacular show of nature's raw power. We're seeing a testament to how much we still have to learn about our cosmic neighbors. Every new observation, every mission that passes by this volcanic powerhouse brings new questions and challenges our understanding of planetary geology. Think about it. Right now, as you're listening to these words, hundreds of volcanoes are erupting on a moon almost 500 million miles away from Earth. Lakes of molten rock are bubbling, plumes of material are being shot into space, and the surface is being reshaped in ways we're still trying to comprehend. This is the reality of our cosmic backyard, and it's more fascinating than any science fiction story could ever be. Before we part ways today, I want to invite you to continue exploring the universe with me. If you've enjoyed this journey through Io's volcanic hellscape, make sure to subscribe to Exploring the Universe and turn on notifications so you won't miss any of our future cosmic adventures. Share this video with your friends who love space as much as we do, and join our growing community of space enthusiasts across all social media platforms. And speaking of future adventures, you won't want to miss our next episode. We'll be diving deep into another fascinating Jovian moon, Europa. Imagine a world covered in ice, hiding a mysterious ocean beneath its frozen surface. Could this ocean harbor life? Well, that's a story for another day. Until then, keep looking up and wondering about the mysteries that await us in the cosmos. This is Exploring the Universe, where every week we embark on a new journey through the most fascinating corners of space.